Hello guys, this is Sushant. So welcome to your channel, which is Sci Engineers. We have been uploading videos for your preparation for the first year of engineering subjects like applied mathematics, engineering mechanics and basic electrical engineering. To get the regular updates from our channel, you need to just subscribe to our channel and hit the bell icon to never miss a notification on us. Also, do like our videos and share it with your friends so that it inspires us to make more videos for you and help you in your preparation. So thank you guys for all your comments and suggestions in the comment section. We will be looking forward to more comments from you and more support from you guys. So give your support by hitting that like button and sharing it with your friends. So in today's video, we are going to discuss on the topic which is successive differentiation, which comes under your applied mathematics section. So let's get going with today's video. So in today's video, we're going to discuss on the topic which is Leibnitz Theorem. So Leibnitz Theorem is related to your UV terms, that is your functions which are related to your x, wherein you, let's say that y is a function of u and v, wherein u and v are nothing but a function of x. So you are having the u and v in the product format, so you will be applying your UV rule while finding your derivative. So Leibniz theorem is useful for finding the derivative or the nth derivative of the terms which are present in product format. So coming to the theorem, so it's y is equal to, if you are having u into v, you have to decide which is going to be u or which is going to be v. So generally it is to be taken that you are taking the v term such that it is going to be becoming 0 after some time. So once that is decided, then you can go and see the expansion which is present. It is just nothing but nc0, where un is the nth derivative of u into v as it is, plus nc1 into u n minus 1. So it's becoming the n minus 1th derivative into v1 plus nc2 u n minus 2, which is the n minus 2nd derivative of your u and the second derivative of v. So if you can just have an observation over here, it's nothing just related to your binomial theorem, wherein you are having the degree of one term which is decreasing as we go from one term to the other, and the degree of the other term which is increasing as you go from one term to the other. So in this case, it is nothing but the derivative which is going on decreasing of one term and the derivative of the other term which is increasing. So in this case, you can see that we are taking the nth derivative of u. In the next term, it is n minus 1th derivative, n minus 2 and so on. For v, it is the increase in the derivative. So we have a v which is without the derivative, then we have the first derivative, second derivative and so on. So it's just nothing but your binomial theorem expansion, just like that. Now you will be just finding the values of nc0, nc1 and all that. So you will be getting this simplified version of the formula. So let's see how we are going to apply this particular theorem in our problem. So let's see this particular problem. So let's see this particular problem which is given, wherein we have a x raised to 4 into cos 3x which is present. So it's basically a uv term which is present over here. So you need to decide which is going to be the u term and which is going to be the v term. If you can just recollect the Leibniz theorem, you have the u term which is starting with the nth derivative and the v term which is starting without the derivative. So in this you have to remember, if you are having two terms such that one of the term is going to becoming 0 after some time, that is if you are taking the derivative continuously and it becomes 0 after a certain amount of time, then you need to take that thing as v. So in this case you are going to take your x raised to 4 as v and this thing will be your u. The reason for this to be v is because if you are going for the fourth derivative of this term, after the fourth derivative it's going to be a 0 term which is associated with it. So directly writing the nth derivative of it, so yn is equal to nc0 which is going to be 1 into the nth derivative of this. So it's going to be nth derivative of cos 3x which is going to be 3 raised to n cos of 3x plus n pi by 2 into x raised to 4 plus it's going to be NC1, which is n, into 3 raised to n minus 1, because you are going to take your n minus 1th derivative of this, so it's becoming 3 raised to n minus 1 cos of 3x plus n minus 1 pi by 2 into the first derivative of v, which is going to be 4x cube. Going to the next term, you are having the n minus 2 derivative into nc0, so it's going to be it's nc2, so that comes out to be n into n minus 1 by 2 into the n minus 2 derivative of cos 3. So that's going to be 3 into n minus 2 cos of 3x plus n minus 2 pi by 2 into the next derivative of this. So that's going to be 12x square. So going on to the next term, you are going to have this as n into n minus 1 into n minus 3 divided by 3 factorial into this is going to be 3 raised to n minus 3 cos of 3x plus n minus 3 pi by 2 into the next derivative, that is going to be 24x, and finally it's going to be n into n minus 1 n minus 3 it's n minus 2 n minus 3 divided by 4 factorial into 3 raised to n minus 4 cos 3x plus n minus 4 pi by 2 into 24. So now if you can just see that this is going to be the 4th derivative of v. Now if you go and find the 5th derivative of it, it's going to be 0. So that is why the rest of the terms will not be coming in this. So it's going to be stopping here. So this is nothing but the nth derivative of your uv term present. So in this you have to see which is going to be the u and which is going to be the v. So basically it's the v term whose derivative is going to be 0 after certain time, or it's the nth derivative which you know basically. So you know that the nth derivative of u is going to be 3 raised to n, which is basically a raised to n cos of ax plus n pi by 2. So this is nothing but the nth derivative. So you need to know either the nth derivative of a term, or you need to see that the other term which is present should be getting to a 0 term. So this is how you will be solving your term problems which are based on Leibnitz theorem. So this is going to be the concluding part for your successive differentiation. If you want to make us more videos on this, you need to just write in the comment section below. Do write in the comment section what more videos you would like us to make on which topic you would like us to make on, and also share the videos and like the videos so that it helps us make more videos in the coming future and help you in your preparation for your first year of engineering. So this is Sushant signing off. We are associated with Samartha Vidya classes, which is for engineering and science students, group tuitions for them. We also provide private tuitions for them also. We have been helping students for their preparation for their engineering and the 11th and 12th levels, and also the preparation engineering entrance preparations. So if you want to know about us, you can just email us at samarthavidya@gmail.com, or you can visit our Facebook page, which is for Samartha Vidya. The link for the page and the email address is given in the description below. So you can just have a look at it. So signing off for now, this is Sushant. So keep learning, keep watching, and happy learning. Bye.